Sainath, see, your introduction is already impressive. So you can maybe skip if you want, maybe your family details or something like that, and maybe focus more on your final year project. Okay, because in IITs we have very dedicated and quite extensive final year project. So that will be a good
Yes,
direction to have. For example, मैं IICL में गया था तो they had most of my interview over my final year project only. Okay. Yeah. So that
yes,
will be a good strategy, that essentially tells that you are technically extremely sound. Uh, yes, and also first tell your 11, 12, and then your college. Okay,
okay,
because then what
I will
happens
do
is where you did your BTech from, that gets just erased away because of the information that you are giving out later.
okay,
Okay, yeah, that will be great. So Sainath, yes, so you are an IIT, and so why do you want to join, PSU? Usually that's not the trend we all see.
yes, sir. Actually, since my JE advanced days, uh, from the counseling, I got a seat in IIT Dharawa CSC. Like I would get if I consider it as a before option, apart from the IIT Kharagpur Chemical Engineering or IIT Kanpur Chemical Engineering BTech program. But I choose to have chemical engineering because I was very much interested in petrochemical and process industries side. So I have kept this. I kept the first option as IIT Kharagpur Chemical Engineering, and in my first round only I got it, and I was very much interested about the process industries also.
That's really amazing answer. So why do you want to join HPCL, Sainath?
HPCL, as a, from the as I'm a, as my nate as I grew up in Vizag, I was HPCL is very integrated part in my life from my childhood. Like I know some of the friends of my father who are working in HPCL, and I've really heard great about it regarding how before it used to be a uh, mm, Navaratna and how it turned into Maharatna in 2017 and how it has increased the capabilities. And so I would like to contribute much more into the growth of the company and my personal growth after joining it.
Yeah, that's amazing actually. So what do you mean by Maharatna company? I mean, how does it differ from, let's say, other?
So, from what I have read, Maharatna company is a company which have net profits more than 10,000 crore in a financial year.
Is that the only criteria?
I think there are some other, but the main important criteria is this.
Okay, and what does it bring on the table for the company?
Yes, sir. They can individually commission a project of 500 crore or above, I think so.
I think it's 5,000 crores.
Yes, sir.
Have a look, okay?
5,000. Oh,
Yeah,
yes, sir.
okay, that's amazing. So Sainath, what are the HPCL products that you use?
Uh, yes, sir. Hpcl is into what we'll say LPG, petrol through its retail outlets, and they have lubricants, HP, Cool Tanda, and lubricant engine oils and other lubricating oils. And it also has aviation fuel, which is spread across majority of airports across India. That's it.
That's kind. So what do we use exactly as aviation fuel? Do you have petrol, diesel? What do we have?
Yes, sir. Aviation fuel from the atmospheric distillation unit, I think we will obtain aviation fuel somewhere at the bottom, very close to the bottom. I think majority of it consists of the uh, what we'll say heavier carbons. I think, and it's a mix of petrol as the major quantity. I think so. Actually,
Not exactly. It's kind of refined kerosene actually.
oh, yes, sir. Okay,
It's
yes,
refined kerosene. Yeah,
okay,
petrol will be too costly actually, and it won't give us any additional benefit. So that's why kerosene is very common, and that's why they use refined kerosene actually. So little high grade one.
okay.
Yes.
And I will be more into the products section.
Yes,
Actually,
yes, that's
eh,
okay. These are just general question. Okay, you don't need
mm,
to mind too much about not knowing. So take it all right. Yes. So, Sainath, let's say, yeah, asking you the same question as before. What is second law of thermodynamics?
uh, actually in terms of entropy, the entropy of a spontaneous process is either positive or remains constant.
Spontaneous process.
So
Actually, see,
entropy change.
actually, see, there is nothing like non-spontaneous process. I mean,
Uh,
it could be externally driven, but you don't need to explicitly go for spontaneous process. Okay, for any
okay,
process, it is valid for any process.
yes, sir. Yes,
Yeah.
spontaneous.
Now, can you reframe it, please?
The entropy of any process must be either be positive or remains constant. Entropy change.
Correct. And when does it remains constant?
It remains constant, I think, in irreversible processes.
Okay. So now uh, imagine, let's say I have a a cylinder here. Okay, something like this. It has temperature of, let's say, 300 degrees Celsius. Let's say 325 degrees Celsius, and it cooled down to room temperature of 25 degrees Celsius. So there is this delta T of 300 degrees Celsius. Okay.
Yes.
Yeah. In this case, do you know the formula to calculate entropy change? ds equal to, there is something.
Uh, Actually, delta S total equal to delta S system plus delta S surroundings. So
Correct.
actually, yes, sir. So delta S is actually delta H heat transferred by the temperature
Mhm. So how will you calculate the change in entropy of the rod in this case?
uh, of the S for delta S system. We can calculate the heat loss by the temperature, like I think the initial temperature, the what you mentioned,
So
three.
we have delta T as 300 degrees Celsius or
Yes,
300 Kelvin.
yes,
So how will you calculate that? That's what I'm asking.
uh, yes, sir. I think delta H would be the heat transfer by the divided by the temperature change plus delta surroundings would be also. I think we here the delta surroundings is zero. I think I'm not sure.
Just a minute, Sainath, please. Okay, okay. Yes, Sainath. Sorry for the interruption. Yes. So in this case, can you calculate the delta S? That's what I'm asking.
Delta is
Yes.
okay.
Change
Like
in
you're asking
entropy.
for the methodology or
Yes,
like how I
methodology. I want to know the methodology. I don't really care about the numbers.
okay.
I want to know change in entropy of the rod.
Okay.
You
So
have
if it
given mass, heat transfer coefficient, whatever you want. That's not a concern.
okay, then I would so then I would say that no sir, I exactly can't.
Okay. That's all right. Okay. So, Sainath, what is viscosity?
So viscosity, like the friction between the layers of fluid, like when it's flowing. So
Correct.
actually, if it's yes,
Mhm. So, what is exactly difference between a turbulent flow and laminar flow? How will you define, or you know what, this is turbulent flow, this is laminar flow?
uh, actually we can do it by Reynolds number. Uh, what is the value of Reynolds number? If it is below specific limit, then it's laminar flow, and between some range, it will be in transition. Then after some number, after a limit, it goes into turbulence.
Correct. Now, can you answer it more fundamentally without using Reynolds number?
Uh, Reynolds number, like in laminar flow, the layers go along each other. In transition, the some type of eddies and disturbances come within the layers, like they're not going along with each other. And in once they enter the turbulence region, there will be more of eddies and what we'll say there will be more of disturbances in the layers, like it's not going lam sorry, not going laminar.
Correct. So, can you give me some example where we essentially need turbulent flow, or we, try to get turbulent flow,
Try to get
or try to get, no,
turbulent.
we use turbulent flow actually, because see, turbulent flow has higher energy
Velocities.
losses, energy
Yes, sir.
losses.
Yes.
Yes. So essentially, it's bad for us, but still we need turbulent flow at some places, some points. So can you give me some
Uh,
example?
I think we can use it for mixing, like mixing of a liquid into solid.
Correct. Why would you mix a solid into liquid? But okay, yes, good one. Then
Uh, like the we can use it to clear any what will say sediments to get carried away in a river also. To
that's
yeah,
too,
that's not an ideal case, but
yes, yes, that's too specific as well.
it's to a specific case. Or for the apart from this two, I don't remember anything.
Okay, so can you comment anything about heat transfer capabilities of turbulent flow?
Heat transfer capabilities.
Let's say you have two type of flow as a choice. You know, you are an engineer at HPCL and you want to cool down something.
Yes.
Okay, you have external air or fan or something like that, and you want to cool it down. So which type of air will you induce on that particular component, turbulent or laminar, and why?
Uh, I think we can induce laminar one
Why?
because it's what we'll say it's because it's kind of smooth because in turbulence sorry, so we can induce turbulence because I think more rapid heat transfer occurs so it cools down rapidly.
Correct.
Can
So
induce
if you
turbulence.
correct, you
Sorry,
will
sir.
induce turbulence flow as an engineer.
Yes,
Yes.
yes, sir.
So why does turbulence show rapid heat transfer as you just said?
Uh, so because turbulence itself involves with more rapid energy losses, or we can say more what will say more impact on what it's doing. Like in our case, we want to cool it fast. So we want the liquid to cool first. So we are inducing turbulence. Like I'm not exactly getting into the time.
Okay, so for example, you just said that turbulence have mixing in layers, right?
Yes,
So
sir.
if
Yes, sir.
there are mixing in layers, then essentially the heat is getting transported more, better in a better fashion than it is in laminar. If
Yes, sir.
there is no mixing, then the temperature of the lowermost layer increases
Yes,
rapidly.
sir.
So
Yes.
that is the reason. Okay, Sainath.
Sir,
So,
sir, is it
haha.
somewhat related to Prandtl turbulent mixing or something?
Yes, but that's too deep actually.
Okay,
But
okay,
yes,
okay.
something like
Yes.
that.
Okay, thank
That's a
you.
different thing actually.
Forgot, yeah.
Frontal. Yeah, yeah, that's okay. But yes. Okay, Sainath. So, you have amazing profile, and I think you really nailed down the part of you are from IIT and still want to join in HPCL, and also your answer to why HPCL was also amazing. So I think HR side you are doing great. Okay, they could answer, they could question maybe one or two uh, more on this topic because see this question is going to come up most likely. Okay, that you
Yes,
are already at IIT, that to BTech, so how come, and this type of, they always see people from doing MTech. That's not a concern, but this will come, and I think you have handled it really beautifully. Your technical is also strong. See if you can just brush up a little. Nothing
yes,
special, mostly
yes,
to the heat transfer side.
yes,
So what also happen is, so usually they don't go deep, but they just touch the surface of everything they can. Okay, so you are amazing. I think you have a great chances of overall recruiting. So you don't need to worry too much. Okay. Yeah.
yes.
When is your interview?
14th, sir, 14th.
Okay. Yeah, you have a lot of time actually. Almost a week, 1.5 weeks. So yeah, you can do that. Not a big deal.
Yes.
Okay. So Saina, you have any general question or?